Did it surprise you a little bit? Here, let's go through the process. Let's see if you got it right. Okay, so finding the derivative of our cosine, we would instead implicitly differentiate cosine of y is equal to x. Same kind of way, you'd basically take the cosine of both sides of this thing and turn it into that equation. Okay, and that does give us an interval at which that works. Of course, because the arc cosine only works or only outputs an answer between 0 and pi, unlike sine, which goes from negative pi over 2 to pi over 2. Okay. So implicit differentiation, d dx, here, why don't I just write it over here? It's getting messy. Of the cosine of y is equal to the derivative with respect to x of x. What is the derivative of the cosine of y? It is negative sine of that same y and then times a y prime. What's the derivative of x? It's just 1. So we solve it for y prime, and I get 1 over negative sine of y. And of course, we can just throw that negative on the outside of this, and it's negative 1 over the sine of, and instead of y, we will put in the cosine, arc cosine of x. And then once again, we will have to build ourselves a little right triangle. Use the Pythagorean theorem to resolve this thing. And let's label our little pieces here. So the arc cosine that's on the inside, that's the angle measurement. It's like this. Burp, burp. The cosine of something is equal to x, or x over 1. The x is supposed to go on the adjacent side, and the 1 is supposed to go on the hypotenuse. And then if I use the Pythagorean theorem, just like we did before, is going to be the square root of 1 minus x squared. Okay, and I want the sine of that. So the sine is supposed to be the opposite side over the adjacent side, which is just this square root of 1 minus x squared. So we get y prime is equal to negative 1 over the square root of 1 minus x squared. What's kind of surprising about that is the fact that it is the same exact derivative as the arc sine, only it's negative, right? If I scroll back up here, you can see that very plainly. There it is. It's the same exact one as arc sine, but it's negative. Okay. All right, let's do one more of these, and that's the arctangent, right? These are the most common ones that come up, and to be honest with you, it's going to be arc sine or arctangent. Those are the two that come up most frequently. Okay, but I'll give you the derivative rules for all of them when we're all done. Find the derivative of arctangent using implicit differentiation, blah, blah, blah. Same exact thing that we've been doing all along. So I have this equation, arctangent of x, and I do not have a derivative rule for it, so I will go ahead and take the tangent of both sides of this, because I do have one for tangent, and then just use some implicit differentiation on it. So I have the tangent of y, tanny, is equal to the tangent of the arctangent should cancel out over this particular interval from negative pi over 2 to pi over 2, just giving me x back. Now let's take the derivative of both sides with respect to x. Derivative of tangent of stuff is supposed to be the secant squared of stuff. And then multiplied times the derivative of the interior function, dy dx. And the derivative of x, still pretty much 1. And then whenever we go to solve for dy dx, I get 1 over secant squared of y. I don't want the y in there. I will instead replace it with the arctangent. 1 over the secant squared of the arctangent of x. And then, as we've done 45,000 other times, right here, that's going to establish an angle. Let's draw a triangle for that thing. Specifically, it is the tangent of some sort of angle is supposed to be equal to x over 1. Opposite over adjacent. Draw a picture. Whoa. We'll draw it over here in quadrant uno. That is Spanish for quadrant 1 for my non-Spanish speakers. Okay, so here is my angle, and my opposite side is x, and my adjacent side is 1. And then use the Pythagorean theorem on this one. It's very simple. It's 1 plus x squared, square root of 1 plus x squared. Now I want the secant squared of that. Well, the secant squared, let's see, secant is the same thing as cosine. So let's do the cosine, well, the reciprocal of cosine. Let's start with cosine. The cosine of this angle is supposed to be equal to my opposite side, no, my adjacent side, sorry. The adjacent side over my hypotenuse side, which is 1 plus x squared, okay? And then I don't actually want cosine, I want secant, so I do need to flip that thing over. So my secant of this angle measurement is the square root of 1 plus x squared over 1. 1 that's on the denominator, of course, is not going to do anything. And now I want to square both sides of this thing. Right, and I will get the secant squared of my angle measurement is equal to, and the square root and the square are going to cancel out, just give me 1 plus x squared. That is supposed to go in the denominator here, meaning that my derivative, dy dx, is equal to 1 over 1 plus x squared. Right, notice that there's no square roots this time. The reason why there's no square roots this time, of course, is that we had to square it because we had the derivative, which was secant squared. The derivative with respect to x of the arctangent of x is equal to 1 over 1 plus x squared. I wonder how the chain rule will affect this. Let's take a look. Back over here in PowerPoint and get to all the derivative rules, which are right about here. Okay, so notice again that the arc sine derivative and the arc cosine derivatives are identical to each other, but the arc cosine is negative, whereas the arc sine is positive. This is the chain rule part of this thing. It's the arc sine of u, derivative with respect to x of arc sine of u. U is a differentiable function of x. So it's u prime over 1 minus u squared. So that u would be the side, the opposite side on our triangle. We'd have to square it and then use the Pythagorean theorem to get that 1 minus the u squared on the bottom. And then on the top, of course, we're multiplying it times the derivative of the interior function, which is that u prime. Okay. And then the arctangent, same kind of thing happens from the chain rule. I'm going to have the u prime on the top, 1 plus the u squared. Again, this u is being squared on there because of the Pythagorean theorem. And it would have had that square root around it, but then since the derivative of tangent is secant squared, we have to square it, and then you get no square roots anymore, right? So if you put those pieces together, I think it makes it a little bit easier for you to remember these derivative formulas. Here's the one for arc sine, or arcsecant, I should say, and it has a little square root in it. We did not derive that, or the arc cosecant. The reason why we didn't, because those things are not going to appear on the AP Calculus exam, but I'm going to give them to you anyway, because they might show up on your homework problems. And now, one last thing that I'm going to point out about this. One final thing. Look at the signs. Look at the signs between all of the sine, the tangent, and the secant, the arcs, inverses, and all of the cofunctions. Notice that all the cofunctions, once again, are all negatives, right? And it was the exact same thing with the derivatives of cosine, cotangent, and cosecant. All right, the last part of this part of the lesson is going to be specifically applying these derivative rules into some specific problems.